So next topic we are going to see about LEDs. So we have seen about laser. Now we are going to see about LED. LED, in short, in abbreviated form, it is called as light-emitting diodes, and it is a forward-biased PN junction diode which emits light by a phenomenon called electroluminescence. Electroluminescence means I give electrical input, I get luminescence. Luminescence means effect of light. So electrical energy is converted into light energy in PN junction device. Okay. In a normal PN junction device, you have current flow, but LED is a special type of PN junction device which, when forward biased, it is going to emit light, and that emission process is called as photo electroluminescence. Electroluminescence means the process of conversion of electrical energy in the form of voltage or current into light is called as electroluminescence. In all semiconductor PN junction diode, some of the energy will be radiated in the form of heat and some will be released in the form of photons. In silicon and germanium, most of the energy is given out in the form of heat and the emitted light is absent, because and only when you have direct band gap materials, you have light emission happening. So we have seen that, right? But silicon and germanium, it is not possible because they have indirect band gap. So for PN junction diode to emit light, you should not fabricate them using silicon and germanium, and you should fabricate them using group 3 and group 5 elements. So you should use a combination of group 3 and group 5 elements to fabricate your LEDs. So one such, some of the elements are gallium phosphide. You can use gallium phosphide for fabricating or your LED, or gallium arsenide or gallium arsenide phosphide. The number of photons emitted is sufficient to create a visible light source. So LEDs are going to be sources of light. So in optical communication, all the sources will be made of LEDs or lasers. Okay, so for the LEDs to emit light, you need to ensure that the LEDs are made up of group 3 and group 5 elements or combination of group 3 and group 5. So you have binary, ternary and quaternary. Binary means combination of two elements. See here, gallium phosphide. Ternary means 3, gallium arsenide phosphide. I am combining 3 elements. Quaternary means 4, indium gallium arsenide phosphide. So 4 elements are there. Okay, so you can use any combination of group 3 and group 5 elements to fabricate your LEDs, which will ensure that the light emission takes place in the device. So this is the symbol for LED. You can see it's a normal diode, but light is coming out. So you have to put lines indicating the emission of light. And remember, LEDs will always operate in forward bias only. And as I told you how to remember, all the devices which are emitting light will operate in forward bias. All the devices which are receiving light will operate in reverse bias. Remember it that way. Okay. So here charge carrier recombination takes place when electrons from N side will cross the junction and they will recombine with holes on the P side. So electrons and holes, in forward bias P diode, the depletion region width is very, very less. So the majority carriers on both sides will cross the depletion region very, very easily under the slightest forward bias voltage what you give, and this results in recombination of electrons and from the N region and holes from the P region. So the charge carriers will recombine, which will result in production of photon. So the recombination of electrons and holes takes place in the depletion region, which will result in the emission of light. And remember, LEDs are always forward biased, and the symbol of LED is shown here. So when LED is forward biased, the electrons and holes move towards the junction and recombination takes place. In forward bias, the battery, the supply voltage, you will repel the charge carriers towards the diffusion region. So the electrons and holes will be moving towards the diffusion region. So since the depletion region width is going to be very, very small, so recombination takes place, and because of recombination, electrons lying in the conduction band of N region will fall into the holes lying in the valence band of P region. So the difference in energy will be radiated in the form of heat. So energy can neither be created nor be lost, right? So the difference in energy between the conduction band and valence band, which is called as the band gap energy band gap Eg. So that will be radiated in the form of light energy. Each recombination creates a photon. That's why Einstein gave you the formula E equal to h nu. So that relates the energy band gap and the frequency of emitted photons. Okay, E is the energy band gap, E is equal to h nu. The energy band gap will determine the frequency of photons. Okay. So light is generated by the recombination of electrons and holes, and the excess energy is transmitted into the emitted photon. So the brightness of the LED will depend on the how much amount of forward bias current you give. That means how much amount of forward bias voltage you give. The more the voltage you give, the more bright, or I can say more photons are emitted from the LED. Okay. So the basic structure of LED we have seen, it shows the recombination of carriers and the emission of light. So N-type layer is grown on a substrate and P-type layer is deposited by diffusion. So you take a substrate and you first grow the N-type layer, and over the N-type layer you are going to diffuse the P-type region. Then the carrier recombination takes place in the P layer. It is kept the uppermost layer. So you are again going to grow it vertically. You are going to have a substrate. Over the substrate, you are going to have an N-type region. Over the N-type region, I am going to have the P-type region. And N-type is grown on a substrate by normal method, and P-type is formed by the process of diffusion. Okay, and electrons are going to go to the P-type layer and they are going to recombine with the holes, right? So you have to have the P-type layer as the uppermost layer so that the photons will be coming out of the device immediately once the recombination is going to take place. So the metal anode connections are made at the outer edges of the P layer so that it allows more surface area for the light to escape. That's why you ensure that in the P region there is proper way for the light to come out, so that you make the arrangement in such a way that the light and the photons, once they are emitted because of recombination, have a path to come out from the device. So some LEDs are manufactured with the domed lenses in order to reduce the reabsorption problem. So some LEDs will have a lens outside the device to focus the light coming out from the device, so that the problem of reabsorption is going to be not. The reabsorption means the same photons will be absorbed by the LED if they are not allowed to come outside. So in order to avoid that problem, you are going to have LEDs which are manufactured with the lenses, so which will focus the photons to come out of the LED immediately as soon as they are formed.